Good afternoon, everyone. This is Steve Wilson. Welcome to our webcast today on how to find local information and help. Again, we're at the State Water Survey at the University of Illinois. And you know, why that's significant is we house the state's well logs of all the private wells and irrigation wells and any water wells in the state, and also do applied research in the state of Illinois related to groundwater wells, surface water, and atmospheric sciences. So anyway, so we run the private well class, which is funded through the Rural Community Assistance Partnership by US EPA, and we run the program, the private well class, with RCAP, the Rural Community Assistance Partnership, and I'll talk more about them as we go. Okay, if you are an Illinois LEHP or you are a EHP who gets CE credit from NEHA, this is the slide we show at the beginning of each of these webinars about core content, and you can only take the same course every 2 years. It turns out we haven't done this particular webinar since December of 20, and so it's really not relevant as far as you couldn't have, I mean, it's been more than 2 years. But after you take it today, if we offer it again next year, if you're in the NEHA credentialing cycle, and so the example I gave here is if your 2-year cycle started January 1st, then you wouldn't be able to take the same course again until 2025. So if you are looking for credit or you need a certificate, email us at info@privatewellclass.org after the webinar, and we can get you all that information, including a copy of the slide deck if you need it and some of those things. Okay, so today's webinar again is part of our national program. Our class, that's the private well class, is not these webinars. It's actually a 10-lesson class that's emailed to you once a week over 10 weeks. I'll talk more about that later. But this particular webinar is based on lesson 7, which is getting help in finding local answers. And it really does, especially in today's world, there's so much information out there available to well owners in some cases, not every case, related to their well or water quality, or information that might be in your local jurisdiction, you know, county or local health district, or your state health department may have information on water quality, different types of aquifers, local sources of contamination, all those sorts of things. You know, as an extreme example, US EPA has a database of all the underground storage tanks, leaking underground storage tanks, which is, you know, the acronym is LUST. And so you can see that on a map online. I'm not going to talk about that today, but it just popped in my head. It's a very good example to find out if there's any kind of issues near you. So this is being recorded, and we make all of these webinars available on YouTube after the fact. And so if someone misses today, or you know someone who you might think be interested in this, they can watch it. It's not available for CE credit. Only today is a live webinar. And at the end, we will have time for follow-up questions. Katie and I are willing to stay here as long as you need us to. There is either a question box or a chat box on your GoToWebinar window where you can put questions in, and Katie will monitor that during the webinar today. And we will go through some of the questions you all asked in advance as part of the slide deck at the end. And then once that's done, we'll get to the questions that you may have asked today. Okay. Again, I'm Steve Wilson. I'm a groundwater hydrologist with the State Water Survey, and I manage the private well class. Katie Buckley is part of our private well class program. She's a water resources outreach specialist here at the survey. And again, she will help you both. She'll put all the questions together that are asked during the webinar, and also will help with the CEs after the fact. So, and I do want to mention Walt Kelly. He's the head of the groundwater section here at the Water Survey. He's a geochemist, and of all the questions you all asked in advance, he and I go through those a few days before and put together the slide deck, and he certainly is very helpful, especially on the water quality side. So first thing we need to do today is answer a poll. So Katie, if you want to launch that poll, you know, it's important to us that you answer this. so we know who our audience is, and that we also have to share this in aggregate with our funders. And it's good to understand who all is participating. Okay, we're up to 53% of the vote. %. I'll give that a little more time. Looks like Katie put a timer on here and it says there's 36 seconds left, but yeah, especially we do monitor, your activity and how long you're on and all those things if you're looking for CE credit, just because we do our due diligence in that respect. But it's really helpful. Again, if you, it's surprising, 83% and 41% are with a regulatory agency. And I'm going to assume that some of those folks are also a health professional. Typically, that's the case. Okay, we'll call that good. So Katie, you can pop up the final numbers there, right?
Yep, so I'm sharing the results.
Thank you.
All right, I'll go ahead and hide that.
All right, great. Thank you, everyone. Okay, so a little bit about rural RCAP. So the Rural Community Assistance Partnership is a group of 6 nonprofits, and these are the regions they cover. I'm in Illinois, so Illinois is covered by the Great Lakes Community Action Partnership. If you're in California, it's RCAC. If you're in Texas, it's Communities Unlimited. Each works as an independent nonprofit, but they're also held together by this national partnership. And so like the funding for the private well class goes not only to the 6 regions, and they have staff there doing private well work, but also to us and a couple other partners. And so we work with folks in each of the regions. They do the boots on the ground part of our private well program. They hold workshops for well owners and professionals. They do well assessments, and I think that might be the next slide. Yeah, so probably 6 years ago now, we sat down with 12 groundwater and well experts and developed this assessment tool. It's meant to be like a vulnerability assessment of a well or a spring. And so RCAP actually goes out in the field and meets with the well owner individually and goes through all the information that's on this. There's a lot to the well assessment. I won't go through it all now, but they're really useful. It looks at everything from if you have treatment, when's the last time you sampled, where's your septic system, to looking at the site itself and seeing that, are you in a bottom ground where there could be flooding, kind of pipes do you have in your home, all that sort of stuff. And then they can make recommendations to you if there's anything they see that might be a risk for you. And it's totally free, and it's totally up to the well owner if they want to do anything about any of the recommendations they get, but also best practices, why you should sample every year and some of those things. If you want to see the entire assessment, it's on our webpage. If you go to privatewellclass.org and look at resource pages, I believe you can find that assessment. Again, RCAP, as part of our program funded through US EPA, does a number of these every year. I think they've done a little over 3,200 around the country in the last 4 or 5 years. And so it's really a useful way, especially someone who's having a well issue, to identify what might be the cause. So yeah, it's like a sanitary survey for a private well, although it's not binding. Like, sanitary survey, if you're familiar with those, is done every 3 years on a public water supply to look at what vulnerabilities they have. Normally that's done under the legal umbrella of the Safe Drinking Water Act. And so a community water supply would have to fix whatever deficiency they might find. In this case, it's really meant to be an educational tool to help well owners identify where they're, every well is different. And I say that all the time, but it's really true. You very rarely find 2 wells that are exactly the same. The way they treat their water is the same. The pipes in the house are all the same. It's in the same point on the landscape. It's just there's always little differences that make every well unique. And so it's a chance to promote best practices. And also it's a chance for the well owner to understand who they can talk to. And, we hear all the time, for instance, that, well, I can't call my county health department because they might condemn my well. Well, that's not something that 99% of the health departments in the country can do. And I say 99% because there are a few local health districts that have given themselves that authority. But if you're curious about that, you can always call and ask. But like in Illinois, all our county health departments, they can certainly recommend you don't use a well that may be deficient or have problems with bacteria or not, it's not safe, for whatever reason. But it's really up to you as a well owner to decide whether or not you're going to use that well. I should have updated this. It's like I said, it's over 3,200 now. And they've also done a bunch of workshops with professionals to teach them how to use the assessment tool. Now, that program has ended as far as the in-person workshops, but we once a year hold a 4-hour online workshop to talk about best practices for outreach to well owners, as well as how to use the assessment tool and some examples. And so if anybody's interested in that, you can email us and we can let you know when it's going to be. It's probably going to be towards the end of the year. We just held one in December. So I work at the Illinois State Water Survey, which even a lot of people in Illinois don't necessarily know who we are. We're a sister agency to our State Geological Survey and our Natural History Survey. We're all under the umbrella of the Prairie Research Institute, which is an institute on the campus at the University of Illinois. But the Water Survey was started in 1895 because of cholera and typhoid outbreaks and concerns about water quality in the state. As we learn more and more about, bacteria and other issues that might be causing disease, the Water Survey was established to investigate those things. And one of the first things Arthur Palmer did in his first few years at the Water Survey was take water samples from many of the community water supplies in Illinois. And when you look through those old records, you find things like, their city well is 20-foot diameter, it's only 22 feet deep, and it's right next to a privy and a barnyard. And that was common, those sorts of things for small towns. All that documentation we still have. So we have records dating back to 1895, which is really cool to go through when you're looking at a community and watch how it's grown over the last 125 or 30 years. And so, yeah, the Water Survey is 128 years old this year. It's a really cool place to work in that respect, not only for the public outreach and education we do, but also the research we get to do, looking at contaminants and issues of groundwater supplies and other things. Just as an example, this is a typhoid outbreak in Pana, Illinois in 1916. And we investigated this. There's a whole binder full of material from when our staff went down there. They weren't welcome. When they first blamed the Pana Ice Cream Company for their tainted milk was causing the cholera or the typhoid outbreak, the ice cream company threatened them and all these things. And in the end, they proved that it was. Everyone got their milk from the same big vat and used a bucket to get it out. That became contaminated and it led to all these cases. And so it's really interesting because they had a water treatment plant, a brand new one built in 1914, and they didn't run it because the mayor said it cost too much to run, and only half the town was sewered. And so you had all those issues going on at the same time, but it turned out to be the ice cream company and the milk that they sold. This is just another pictures from New Athens, Illinois in 1914. And this young man is helping a water survey chemist do some water analysis, which again, these are all in our files. It's a lot of cool information. I guess I show this stuff because I'm proud to work here. We've done a lot of good in the world and continue to do things that are on the cutting edge and as far as research and helping solve water quality problems. So moving on, the important things to know about your well as a private well owner, they're not regulated. It's up to the owner and the user to be sure the water is safe. And I say user because of folks that may rent a property with a well and the system is maintained. I know there's one state, Vermont, I believe, that has a law that says if you're a renter, you have some rights related to having a private water supply. I don't know how well that's enforced. Well water can be the best tasting and safest, but it can also have contaminants that are odorless, colorless, and have no taste. And a great example of that is arsenic. Well, most states have at least some aquifers with arsenic in them, including Illinois. You can't see it, taste it, or smell it, and it's naturally occurring. So we have certain aquifers where it's part of the source grain material, and depending on the chemistry, it's released into the water. And so we see, the health standard for a community water supply is 10 parts per million, or 10 ppb, sorry. And we have wells in Illinois that are be as high as 450 or 500. And, it's just a problem. And so you don't know unless you test. And that's kind of the message. So I grew up on an old dug well. It was only 14 feet deep. My grandpa hand dug it in 1933. Now I know, I didn't then, that it was always contaminated with bacteria, especially because it wasn't safe and wasn't protected at the surface. Now I live in town. I pay a water bill, and that $40 or $50 a month, which is more like 50 to 70 now that I have an 11-year-old daughter, is what I pay so that I know I'm going to have pressure when I turn on my tap. There's always water available. I know it's safe to drink, and I don't have to pay for piping it or the pump or any of those other things for maintenance. That it's all being done for me. As a well owner, you're responsible for all those things. And going back to our dug well, the well I grew up on, it was in a little well house, but it was in the bottom of a ravine. So water ran to it from 3 sides. And in the winter, I grew up in Illinois, we had really cold winters. If our power went out, we had to use a propane tank in that little building to keep the pipes from freezing. And if that propane tank ran out, our pipes would freeze and burst. We were without water for weeks, for a full week one time. And it's just, there's a lot to do if you're a private well owner in order to maintain your well. And that's a poor example just from the standpoint that it was not a properly constructed well. It didn't have a pitless or anything to keep everything below ground so that it couldn't freeze, a lot of those things. But there's still a lot of wells like that out there and in use. So it's really about, the whole point of our program is to help you become more aware. If you have a well log, or you can find your well log, that's going to come up today several times. Understanding where your water's coming from. Do you have a well screen? So it means it's in a sand and gravel most likely. Or do you have, how much casing do you have? If it's a bedrock well, it could be a 200-foot well, but you can only have 30 feet of casing if it's an older well. Where's the pump set? All those things matter when you have problems, if you run out of water, or if you're concerned about surface influence getting into your well water. So not only those things, but there's natural occurring contaminants. I mentioned arsenic, uranium. There's others that are just part of the matrix of the bedrock or the soil or the grains in your aquifer that could be a contamination issue, or at least a health risk. So the point here is, the more, if you go through the class, the 10 lessons, and participate in these webinars and ask questions, you're going to learn to ask better questions. You're going to understand enough about your well that you'll be able to ask better questions and understand those answers better and know how to deal with any situation you may have. So, and lastly, sample your well. There's no substitute for taking a regular sample and understanding what the water quality is in your well. So what we're going to discuss today, well logs, and I should have changed this third bullet. We're not going to talk a lot about financial help today, because next month we're having a webinar on funding and financing for wells and well-related issues like abandoning wells, septic, and sampling. And so I'm not going to cover that today. We have actually one of the largest programs on financial help for well owners is managed. It's a grant and loan program from USDA. And we have 2 folks from USDA who are going to be on our webinar next month to talk about those things. So I'm just going to touch on it with a couple slides. But we'll go through some examples. The idea here is there's actually, in most cases, there's a lot of good information available locally or within your state. And if not online, then there are people who are your resources, and you just need to figure out who they are. And they're more than willing to help you. I mean, a lot of times, that's my job here. A well owner calls, or someone recommends a well owner call me, then, especially in the state of Illinois, I've got our logs available. We've got water quality information available. We try to help them with the response. And so that's really what we're about today. So as far as getting local help, the best support you can get is locally. And that's because they understand your geology, your wells, your regulations. If you have any kind of natural occurring contaminant, where it's at, just like in Illinois, um, if a well owner asks about Tazewell County knows, the health department as well as we do, that there's arsenic there in the major aquifer there. And so that's one thing we would recommend they definitely test for. And it's really getting to know those folks and trusting them and know that you can rely on them. There's a lot of other folks you can deal with too, your contractor, well driller, co-op extension, and I listed a bunch here: DNR, DEQ, DEP, DPHs. It depends on what they're called in your state. In Washington State, it's the Department of Ecology. Regulates well construction and licenses drillers. You need to find out who those folks are in your state and what agency they work for. I know someone asked a question about Georgia, and the folks that license drillers is Environmental Protection Division. I think it's called EPD. Yeah, and so it just depends. But you can Google that, and that's one of the things we'll talk about today. And you can find out who does what in your state that way. Your driller is your best source of well information about your well. If you know who drilled your well and you've talked to them, that's your best bet, especially the person who actually did the physical drilling. So they're going to remember your house. They're going to remember what if they ran into anything. And the problem is that many times you don't know who that is. There may not be a log. You bought the house and already had a well. And we have run into a few cases, the drillers keep logs of every well they drill, and that's kind of their sacred, if you will, information. That helps them understand if they go back in that area and drill, they know that that's what they found, how deep to get to an aquifer, all that sort of thing. So in a few cases, we've run into situations where a driller won't share a log with a well owner. That's not the common thing, and I would press them. If that ever happens, you can even contact us and we'll press them. But yeah, the other next thing is the agency that requires logs to be filed. Now that I say that, even though in a few states they're not required to be filed, or they weren't required to be filed until not too long ago. So a couple examples. I just learned today in Georgia that they don't have to file logs for private wells if they're under 6 inches in diameter. In Mississippi, it's 5 inches or less, and they don't have to file a log. New York didn't start requiring well logs to be filed until 2000, which is late enough in the game that they only have about 10% of the well logs for wells are actually in use in New York State. So it really varies by state. In Illinois, we began requiring well logs in 1968, kind of ahead of the game there. And so a lot of times you can't find a log, but there's things you can do then is maybe there's a nearby log, and that doesn't necessarily tell you everything you need to know about your well. But if you measure the depth or have a drilling contractor measure the depth of your well, you can use a nearby log to get an idea of what the geology might be, for instance. And there's still a few states that still don't have, well, I said PA and Mississippi, but there's 2 states that don't even require don't have well construction code or some of those things, and that's Pennsylvania and Alaska. So it's important to know whatever you can know about your well, the depth, the geology, the well type, is it a sand and gravel well, is it a bedrock well? And so you understand, where your pump's at, where's your water coming from, which aquifer. It depends on how much casing there is and if there's a screen, all those sorts of things. So having a good log is critical. And if you're going to drill a well, and I'll talk about this several times, but make sure your contract with your drilling contractor has in it that they give you a copy of the log, and that they do a pump test when they develop the well, which, when they drill a well, they get mud down in the well. They pump that to clean it out. They can also use that time to put in a larger pump and do a pumping test. And I'll show an example of that on an Illinois log where they pumped it at 25 gallons a minute for 2 hours. And you can see they measured the static water level before they pumped and the pumping water level to get an idea of how much drawdown there is. So there's a lot of things on a log that can be really valuable. to understanding how much water you might have, what the, how much water your well could actually produce long term, all those sorts of things, if it's filled out and if it was all recorded when the well was drilled. So as an example, if I Google California water well logs, and if you do this for any state, I did it this morning for Georgia water well logs, and you can find information. And so in this case, so California is an interesting state in that until I think 2016 or 2017, water well logs were not public information. You had to, when we first started this program, like in 2013, I had a California well owner contact me, and I said, well, I really need to see your log. And he didn't have it. And so I called the county he was in, and they had the log, and they would not give it to me. They said the only person who can get the log is the well owner. And so I contacted the well owner. He had to go to the county and get a copy, and then he faxed it to me. But now today, I think in 2016 or 17, they passed several laws to make all this information more open as they started having drought issues. And now you can see every well log that they have a record for under water.ca.gov under Department of Water Resources. And it's really a well done site. And it's kind of one of the better examples of a state putting all this information out there. Illinois also has our records publicly available. We have a GIS tool to look at those if you want to, and you can get information down to the actual scan of the log. And so in this case, when you go to the Open Data Portal on California's website, you have a list of things. If you know some of the things you're after, like if you know the well numbers, or you need a well number, or if you're just looking for the completion report, again, there's an ArcGIS map service that to look at that data. And so if you look for the features, there are no, okay, so yeah, so I did the ArcGIS feature for well completion reports, and it gives you the URL and the information to get there. And as you look at this information, this is all the metadata that goes with it. It talks about the layers and tables. But up at the top there, it says there's an ArcGIS online map viewer. So I looked at the footprint first, which gives you all the information. If you're a GIS person or you want some of the metadata for these things, it gives you all that description. But then once we get into the tool, you can move around, and I can't remember what county I'm in here. But yeah, you can zoom in and you can see this is just the base map with the wells. I clicked on a well and it tells you all those details. And so, there's, you'll notice like some of these logs seem to be in a pattern. That's because of the way the locations are filed. They weren't necessarily filed with an actual lat long or a specific, feet from section corner type of thing. They might have been, if you use a land survey system, it's by section, quarter section, and 10-acre plot. And so that if they don't have information, the best solution is to put the location in the center of the 10-acre plot. And that's why you see some of those wells that way. But you can, if you know where you live, this is in California, you can go find your well and look at that information. And then once you have that, we're in Fresno County, you can get the well ID, and that takes you to even more information if you want to. So same thing, New York has a tool. There aren't a lot of well logs here, but for the ones that are available, this is near Buffalo. And so again, you can click on a well and you find out that, this is a 45-foot deep well. That's only 19 feet to groundwater. Doesn't have a screen because it's a bedrock well. All those sorts of things. So this is a limited data set. And if I look at this actual, the actual search results, you can see all the wells that are near this area in Lewiston and Lockport in Niagara County in New York. The lat long, the depth, where they hit bedrock, the casing depth. So in a lot of states now, they have a minimum casing requirement of 50 feet. And I don't know which states for sure do or don't, but originally, or before there were a lot of rules, You drill a bedrock well 10 to 20 feet into bedrock and you seat the casing there, and the rest of the hole is just the open hole of the drill bit that creates a hole, and that's so you can take advantage of the fractures in the bedrock. And so where that's important is like these two wells where it shows casing length in feet is 19 and 10, a little over halfway in the column. That's not very far to have casing. So if it's bedrock at the surface and there are fractures in the rock that are letting water into that borehole, there's also likely fractures going up to the surface, letting surface water get into that part of the aquifer. And so only having 10 feet of casing makes it more susceptible. And I went to New York, it's probably been 5 or 6 years ago to work in the Buffalo area. And there were wells that are 300 or 400 feet deep, but they still only had 15 or 20 feet of casing. So when someone says, well, my well's 300 feet deep, that's not what's important about a bedrock well. It's how much casing there is. And so in this case, you know, this 80-foot well has 19 feet of casing. That means water can get in the well from 19 to 80 feet versus if this was an 80-foot sand and gravel well, it probably has a 4-foot screen at the bottom. That means water can only get in a sand and gravel well that's that deep from 76 to 80. And so it really makes a difference understanding your log, what type of well you have, and this is just an example. This is also from their website. This is the log that was turned in. This isn't ideal. You know, the well's 6-inch. The well depth was 42 feet. It pumped 15 gallons a minute. The water table was at 27 feet. Then they hit a water zone, it says here, at 31. And they, rock after 1 foot. So it means they hit a fracture down at 31 feet that provided water. Not a lot to say here other than this isn't an ideal log. There's a lot of information that's not on here. I'll show you some better examples. So Illinois has, through our State Geological Survey, which is our sister agency, they've developed this interactive map called ILWater. Poor choice of names, but Illinois Water. And it's on their front page, and you go to the interactive map. It shows you all the water well logs in the state. I've zoomed in to near Champaign-Urbana, which is where the University of Illinois is. You've got all these layers you can turn on and off, and the brown there is the aquifer, and so you see wells that are off the major aquifer. That doesn't mean there's not shallower sands and gravels, which in this case is all we're dealing with. There aren't any bedrock wells here because we have 300 or 400 foot of glacial drift over top of bedrock in this part of the state. But as you zoom in to a well, you can click on it and it gives you some information. The GeoSurvey uses API number. The Water Survey uses a P number, and that's from historical differences in the way things were done before we moved into the U of I when we were separate agencies. But this is a 269-foot well. If I click on that API number, it gives me a generated log from their database. So they've entered all this information, and someone, a geologist, has actually went in and helped identify those geologic layers. It provides some information, but it actually doesn't provide everything that was on the original log that the driller filed. But all that information's here, and we're working on, it's not done yet, but many of the well logs now will link to the Water Survey's scan as well as this generated log. And so if I click on one of those blue get file buttons, it gives me the actual log. And so this is the log the driller filed in 1968 for that well. It's only, let's see, it's got a 7-foot screen, number 14 at the bottom. It's got a 50-inch concrete pit from 0 to 5 feet. So back in the day, this was done in 1959, you put wells in a pit in a cold climate like Illinois because you had to keep it below the frost line in the winter. And so today we use pitless adapters, and you don't have these pits. They're dangerous. Livestock, tractors, people fall in them. If there's a heavy rainstorm, they can flood and the well might be overtopped. But then, so there's 5-foot of 50-inch concrete pit, and then there's 4-inch casing down to 162 feet. You can see the geology on number 18 on the bottom right. Clay and rocks, blue clay and rocks, compact sand and gravel, 25.5 feet from 143.5 to 169. And so they put the well screen, a 7-foot screen, from 162 to 169, and the rest of it's solid casing. They didn't say what it is here. It's probably with steel. And the other really valuable thing here is number 17 at a static water level of 91.6 or 91.5 feet from ground level. They pumped it at 15 gallons a minute for 2 hours, and it lowered to 117.5 feet. So they were just using the steel tape back then to do this. Now we have much better measuring devices and they get a little closer. But there was basically 25 feet of drawdown pumping at 15 gallons a minute for 2 hours. And what typically is done when you see this, most homes don't need a 15 gallon per minute pump. So a lot of times the contractor or the driller, he's trying to clean out the well too, they'll pump it harder than it's going to be pumped. And then they'll put in maybe a 5 gallon per minute pump in the end, which is what is sufficient for a home that doesn't have livestock. And so if it only went down in 2 hours, 25 feet, then with a 5 gallon per minute pump, they're never going to have an issue. Now this has a working head pump, which is basically just like an old hand pump, but it's got a motor on it that does the pumping. So this is at the surface. It says working head. If you look at number 5, these aren't in use today. I run into them every once in a while. They've got a pulley. They're sitting on top of the well. It's a big mechanical device with a motor. It's not a good thing because you've got to grease it and all those things to have on top of your well. But it's probably been replaced, but this is the way it was put in 1959. But there's a lot of good information on this log, that's for sure. Here's a second log. This is newer. This was drilled in 1980, and this is a camp. So it's a non-community water supply in the end, but it's a little larger well because they're supplying a full camp. And a lot of the things here are the same. If you look at it, you can see they had broken limestone, so they hit bedrock at 187 feet. And so this is the bedrock example. You don't have a screen, right? There's no screen. Number 14 is blank. And so they use PVC to 179, and they use black steel from 179 to 199, and they hit bedrock at 189 basically. So they use steel casing 10 feet into the rock, and then you seat that and seal it into the bedrock so there's a good solid seal. And then they use PVC because it's cheaper up to the surface. But then below 199, there is no casing at all. It's an open hole. And that's just whatever size they drilled. It looks like, where's that at? Looks like they drilled a 5-inch hole to 260. And they stopped when they hit shale because shale is cemented clay and it doesn't provide any water. And so the water here is coming from the limestone from 189 to 257. Whoever filled out this log in the office and typed it up, number 12 is wrong. It says shale from 257 to 260. That's because the person in the office is used to the last geologic unit that they drill into is probably where most of the water is coming from. But in this case, they listed 3 feet of shale and decided to stop. And actually, again, the water's coming from the limestone. They pumped it at 25 gallons a minute for 2 hours, and it went from a static level of 130 to a pumping level of 160. So it went down 30 feet, and they probably put a 15, let's see, it probably says in here, yeah. On number 5, they put in a 12 gallon per minute pump. So they pumped it twice as hard as the pump that they actually needed for the camp, and that means they're gonna have less drawdown, and it's probably gonna be sustainable. And the neat thing here is, in a lot of cases, the limestone starts at 189, but the water level was all the way up to 130. So the water rose in the well pipe well above the aquifer, which means it's under pressure, and that's considered an artesian well. Artesian doesn't mean flowing out the top. Artesian means greater than atmospheric pressure. So if you put a well in somewhere and the top of the aquifer is at a certain depth, if the water level in the well is higher than that, that means the entire aquifer is pressurized and it's working against, it's not under atmospheric pressure. It'd be like if you had a jar of sand. Well, let's just leave it. It's an artesian aquifer. Too many concepts today. Other things we can look at. If you want to find your aquifer, find out if there's an aquifer in your area, a major aquifer versus some minor thing that you might have hit. The driller may have hit a 4-foot section of sand. Well, that may not go very far in any direction from where he drilled. But a larger aquifer that's dozens or hundreds of feet thick is likely more extensive. It was put down, if it's sand and gravel, by glaciers. And so when I just looked at Oklahoma aquifer maps to get an idea, and they also have a really cool website that provides a lot of information. Especially, they have a lot of monitoring wells where they monitor water levels in the state. So I clicked on a map of aquifers from their water agency, and I get this nice PDF. And so you can look at where, if you lived in Oklahoma, these are the major groundwater basins, if you will. And alluvial means near a stream. So any bottomland, like I grew up near Salt Creek in Logan County, Illinois, and the bottom ground for that, where the floodwaters would first go, the creek itself was probably only 100 feet wide, but the bottom ground where it used to run when the glaciers melted and carved out all the landscape is probably 3 miles wide. And so when there's a lot of flooding there, you'll have 3 mile wide thing of water, flood water, until it recedes. All of that bottom ground like that is usually really sandy because that's what gets deposited whenever what drops out first. And so that's called alluvial. It means it's deposited by flood water or running water. So the major alluvial aquifers it mentions here, most of their aquifers are along river valleys. And so that's what this is showing. You can look at groundwater wells, going back to this page, and this, you get a map like this. This is intimidating at first, but you can zoom in like I did on the Illinois map, and all that stuff spreads out to your area. And I circled the little layer button at the top because all of these layers that show up on the left, aquifers, groundwater standards, groundwater wells, you can turn on and turn off each of those individually. And that shows you, I have groundwater wells turned on, so it's all the wells, and I have aquifers turned on. And within aquifers, there's more branches to each of those, and I can turn on and off specific ones. But the first thing to do is find out where you're at. And again, not every state has these. I'm just showing you some examples of states that have provided this information. But if I'm in Oklahoma and I don't want to mess with this map, or I don't really understand it, I can call OWRB and someone will help me. And that's the other message here, is to understand that the folks at these agencies that provide these maps are more than willing to help you if you'll tell them, here's where my home is, here's my address. I get that all the time. Here, someone will call and say, hey, I just bought 5 acres out in the country. Here's the location. I want to drill a well and put a house up. I can go look at our information and look at other well logs and say, yeah, you're in it's going to be a 250-foot well. It's going to be high in iron and manganese. You're going to want to do something about that, but it's a good water supply, blah, 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 blah. So I zoom in here, and again, I clicked on groundwater wells, and it's, right now I have clicked groundwater wells, monitoring wells, other wells, reported well logs. So it's everything under the sun. And I don't have it showing there, but the different colors mean different things. And so if I back that off, what I did is I added major bedrock aquifers to look at, where the major bedrock aquifers are in the state. And it shows we're in this big green blob here is one of the major aquifers in the state, which is why there's a lot of water well logs there, because there's a known water supply. And then if I have minor alluvial aquifers, again, what do those look like? They look like a stream, right? That's the bottom ground, the floodwater areas for rivers and streams. And those are typically very sandy. We see sometimes even communities that are in areas where they don't have a good aquifer may pipe water 4 or 5 miles from an alluvial aquifer along some major river back to their community because that's where the water is. If I just say reported well logs, I don't remember exactly what the definition of reported water well logs or reported well logs is versus groundwater wells. I think those are the ones that are drilled by drillers for private wells and things like that. But then I can just add other things in. These are the monitoring wells they have. You know, if I see a clump of monitoring wells, I'm asking the state why they're there, especially, you know, a lot of times monitoring wells are put in because of a known source, you know, old landfill, old gas station, whatever it might be. And so that's even useful information. If you happen to be right next to a bunch of monitoring wells, I'd find out why, for instance. And then added groundwater wells, and I clicked on one, and you can see who the owner is. It's 60 foot deep. They hit water at 19 feet. And this is, again, it only pumps 2 gallons a minute, but it's a pretty shallow well. Versus this one's 1,200 feet deep. They hit water at 380, and it pumps 75 gallons a minute. You know, if there's an irrigation well in here, it may pump 1,200 or 1,500 gallons a minute, but you need to be in an aquifer that'll sustain that kind of pumpage as well. And so this is obviously a deep bedrock well. All reported well logs. Okay, yeah. So this is their front page. I think I was just showing this so because you can do a water well record search. That's where the yellow thing is. And from that, then you can start searching based on information. So this uses legal description. If you know the well ID, that's probably your best bet. But also, you know, township range and section, that's how our well logs are filed. But if someone, and what I do, if someone sends me an address, I look it up on a map and figure out how to put that on a topographic map to determine the township range and section, because it's much easier for me to find a well log that way. And then here's the result from the search I did. You can see that there's mostly domestic wells. If you look at use, there's one public water supply well that's 370 feet deep, and an observation well that's probably close to that actually. And then the rest, there's an irrigation well and then domestic wells mostly. So there's, yeah, it tells you who the owner is. So this information is all public. And again, it depends on what state you're in. Many states today do provide that if they have that information. And so it can really be helpful. Again, I did this just by searching for aquifers in Oklahoma aquifer maps. And if nothing else, if it didn't come up, nothing good came up, it should give you the organization or the state agency that has that information, and you should be able to go to their website and find a number to call to get you started. And it may take a little effort, but if you want to know about your well and your aquifer and conditions near it, you need to do your due diligence. That's the bottom line. Even monitoring, this is great, they have these online. We do too. We actually have a series of, I actually installed a bunch of monitoring wells in the 90s throughout some parts of the state. And we have telemetry on those and automatic recorders. And you can go on our website, the State Water Survey's website. I should have showed one of those examples. And look at water levels from the last hour, which is really awesome. Because if you're near there and you want to see what's happened in the aquifer in the last year, if it's been really wet, if it's been really dry, you can take a look and it'll show you how things have changed. Or in some of the areas, we have a lot of irrigation, and you can see during the summer how much the water levels go down in a particular aquifer. And if you know where your pump's at and you're nearby those areas, it may be a good reason why, if you start to have an interference problem, or you're not pumping water like you should, it's just, again, it's all useful information, and you're learning about other uses in the area. Depending on where you live, if it's out west, they have a lot of water rights related to who can pump and how much, and you're allocated a certain amount. In Illinois, it's the law of reasonable use, which basically is no rules other than if you impede somebody else's use, they can sue you. And that's typically what has to happen is if one use impedes somebody else's use, you have to deem it unreasonable and you have to take them to court to have that settled out, which is not the best way to do things. So yeah, Google first, see what you find. If there isn't a great site like any of these, then, and I didn't show water quality, I think I will in a minute maybe, but there's still information about the agencies that houses information, even if they're just a PDF map that's, a statewide and doesn't give you a lot of great information, that gives you somebody to call or email. And if you tell them what you're looking for, I want to know more about my well and my water quality and the geology in my area. There's folks like me in every state that do that and help well owners all the time. And now with the program we have, I actually get to do that with folks around the country. Although a lot of times I'm trying to find them someone locally because they know a lot more about the area than I do. Another thing that's important is about what to test for. It really depends on a number of things. What formation, meaning the geologic formation it's coming from, does it have known natural contaminants, all those sorts of things. If it's a shallow well or if it's a well that's doesn't have a great protection, if it's an old dug well, for instance, then there's more likelihood of surface contamination. And so you do have to consider your individual situation. But what I'll show you here next is we have a list of things we recommend kind of as a nationwide example of what people should test for. And what I tell folks is use this list, sample for these things, but also find out if there's anything else in your area that you need to sample for. Or look at your surroundings. Do you live next to a gas station? Is the easiest example. Because if you do, then maybe you need to consider it's more expensive, but sampling for hydrocarbons or whatever, or at least look up like on US EPA's website to see if there are any underground tanks close to your area, really close, that are a problem or on their radar. Most gas stations would be shown there, and if there's any problems, it would show those things as well. And so if you have any identified contaminants, you should ask Co-op Extension, ask the well records folks in your state. Other folks, drillers that drill in the area will know if there's anything. Whenever all the arsenic stuff happened in Tazewell County, it was around 1985 when they really realized there's a lot of arsenic there. We had drillers contacting us about how deep should I drill, because the aquifer is 200 feet thick. So do I put a well on the top of the aquifer, the bottom of the aquifer, whatever? Well, we've done a lot of testing and sampling and found that it really didn't matter. You might find it's kind of potluck, if you will. You'd have wells that were in shallower units that still had high arsenic. You'd have wells that, near a well that was really low. And so, but when you can identify those things, a driller will know what's going on in your area. And then again, we recommend sampling for coliform and nitrate annually. So neither of those things will hurt an adult, right? Coliform is an indicator bacteria. It's not E. coli. E. coli is what makes you sick. And nitrate is considered, it's a health risk for babies and pregnant women because of blue baby syndrome, but it's not on the EPA's contaminant list of health risks because it's a risk to adults. The reason we sample for those things is because they're very ubiquitous in the shallow environment. And if you find them in your well, it means that there's a pathway from the surface into your well, and there shouldn't be, right? Your well should be protected at the surface and have a good well cap, and it should be grouted around the annulus, which is putting clay or cement around the outside of the casing to keep the borehole from being a conduit for water to get in. And so you sample. It's an easy, cheap way to ensure that you to give you some peace of mind that your well still has integrity and nothing's getting in from the surface. It doesn't mean your well's safe. and have so many people who've only sampled for coliform and nitrate and like, oh, my well's safe. You don't know that, there's not arsenic or uranium or whatever else there could be. You got to test. So a couple examples. This is on DEP's website for Massachusetts, Department of Environmental Protection. They have this, they've done enough sampling in the state to know where there's arsenic and uranium most likely present in different bedrock aquifers. So they've created this tool. You can type in your address and it'll tell you if you're at risk of either arsenic or uranium or both. And then there's up on the right, there's fact sheets and information to tell you what you can do about that if that's a problem. But you don't need a test for uranium if it says you don't, in most likelihood. So it's a way to kind of screen based on where you live. This is the state of Rhode Island. All those little dots are where there used to be orchards that used arsenic as the pesticide for the orchards through the 1960s. And because of that, there's a ton of soil contamination in these small areas. So if you live near an old orchard or a current orchard that's been there more than since the 60s, there's a lot of soil contamination and some of that is leached down in the groundwater. And so it's a risk if you're a well owner in those areas. The reason I show this though, and I've said this 100 times probably, is because of the big splotch in the middle. That is where there's naturally occurring beryllium. I honestly didn't realize beryllium was even a regulated contaminant on the under the Safe Drinking Water Act until I found this map on their website probably 8 or 9 years ago. But it's a great example of why you ask and why you look and investigate. Because I would never recommend to anyone to test for beryllium unless they're in this area or unless a local health department or state health department told me that there was naturally occurring beryllium somewhere else, because it just doesn't occur that often. And but if you look up the Safe Drinking Water Act and what communities have to make sure their water supplies meet for health standards for water quality, beryllium is on there because it does have health effects if you drink water that has too much of it. And so it's just a reason why you need to be curious and do your due diligence on knowing what to sample for. Wisconsin has this tool. This is actually an older slide, but the site's still there. It works great. There's more information than there was when I took the screenshot. But up on the upper right, you can tell it to display what? I said arsenic by county. And so it shows me this map of all the groundwater samples they have from Wisconsin DNR from private wells. So there's a few counties that are clear. You can see underneath, so to speak, and that's where they had no data at the time. Now all of those are filled in. But what this shows you is, the health standard for arsenic is 10 ppb. And the legend in the upper left shows that green is 5 or less, and then you go through the colors to red at 21 or higher. So it's twice the limit for a public water supply. Doesn't mean you can't drink it if you're on a private well. You're not regulated. But you can see around Green Bay, there's 3 counties where arsenic for the samples they've got are all higher than 20. And so if I'm going to move to Green Bay or that area and buy a house that has a private well, I'm certainly going to sample for arsenic first before I buy and find out if they've done anything, if there's treatment, if they have an RO system, or maybe whatever they might have for treatment, and identify those things before I actually sign on the dotted line. And it's I have well owners tell me, or people tell me, well, the housing market here is crazy. They've had 3 offers today, and if I don't buy it, I'm not going to get it. But it's got a private well. And I tell people it's your choice, but you may be spending several $1,000s on treatment equipment. You may have maintenance costs every year. If you feel like you really have to buy it, then that's up to you. It's a personal choice. But what I would recommend is that you get a water sample done before you purchase a home and make sure you know the water quality. And there's always ways to remediate things. There's not anything that can't really be treated. But it's a matter of what the costs are going to be and the level of knowledge and effort you're going to have to put into that. So the point here is there's some really good tools out there. Again, more and more states are trying to put some of this information online, and so it's worth looking to see what might be there. Here's what we suggest, and again, this is for a national audience, so we're not going to list beryllium here or some other things, But again, annually for coliform and nitrate, because that's a way to, indicates a pathway into your well. You shouldn't have either. And then, this set of inorganics and metals really give you kind of a general background and idea of what your water quality is. Copper if you have copper piping, zinc and cadmium if you have galvanized piping, but things, understanding the pH. If you have lead pipes, for instance, in an older home, lead pipes aren't an issue if your water's not corrosive or aggressive. It's only when the water is corrosive that it starts leaching lead or copper. And so, there's a scale, right? That's a bad term, but if your water can either be corrosive or it can be scale forming. And so in some cases, you have lead pipes that have all the scale on the inside that's built up over time. So the lead's not even touching the water. And that's because of the chemistry. And so understanding the chemistry and whether your water is aggressive or corrosive is the best way to know if you have an issue, because replacing all the pipes in your home is a pretty expensive endeavor. So we see a lot of, even in community water supplies, I know they're trying to get lead service lines out everywhere in the country, but in some communities, there's really no lead leaching issue from those pipes because the chemistry is such that it doesn't cause leach to lead. And so it's just good information to have. So when to test, besides what we mentioned in the last slide, anytime the well's been opened, it's probably a good idea because anything can be introduced there. If you just have to disinfect your well because it had a coliform problem or E. coli problem, then certainly you should take another sample once that's all done before you actually start drinking it, boil it until then. And then anytime there's an emergency response event. So we're showing courtesy of El Paso County, Colorado, after a forest fire went through an area that had some homes. You can see what it did to the aluminum cap and the wiring for this well. It's all melted. And, we have some short videos on what to do after a fire or flood. One of the things you should do if you're in an area like that is cut off the power to your pump, because when these wires burnt, if that pump is still on, it could melt the wires such that it turns your pump on and it runs constantly. And if you're in a low flow or a low yielding well, you could certainly pump your well dry, so to speak, and then that pump will burn up and now you've got a pump to replace as well. And so, this well is going to have a lot of problems because melted plastic has dripped down in there and whatever else. But anytime your well's opened or there's any work being done, it's best just to disinfect it to be sure that it's good to go. As far as getting it analyzed, that's a question we get a lot. There's a lot of labs out there. So for community water supplies, they have to use an accredited lab. So every state primacy agency, like in Illinois, that's the Illinois EPA. In Minnesota, it's Minnesota Department of Health. It just depends on your state who the primacy agency is, which is the agency responsible for ensuring community water supplies meet all the regulations of the Safe Drinking Water Act. They accredit labs, and those labs have shown that they can do that kind of work and do it well as far as meeting all the standards, using the methods that are approved, all that sort of stuff. There are states that have programs for private well sampling. Iowa has a grants to counties program where their state legislature gives money to each county, either for well abandonment or for cost sharing water samples. Some other states have different kinds of programs on that as well. And when you find a lab, a good lab will give you everything you need. They should be able to answer your questions, give you all the sampling instructions, how to store and preserve it if it needs to be, when they need it back, how to ship it back, all those things. As a well owner, what you should do is ask questions until you're satisfied and you're sure you have a good understanding of what they expect. They should provide the bottles and everything else. And if you run into a lab, even if they're accredited, that can't provide all that information, then I'd find another lab. That's my advice to a well owner. is you don't want to go to a lab that doesn't understand private wells. They have different issues than community water supplies that are sampling their finished water that's being delivered to their customers. And so, they should have somebody on staff that can really help you, or find someone that does. So if you just Google certified or EPA certified labs, you get to certification of labs, blah, 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 there at the top. And that takes you to this page. If you scroll down this page, it shows you a map, which is clickable. So you can click on your state and get to the web page, or you can use the drop-down list of where to find labs in your state. So this is ADM, Alabama. They have the certified labs are listed there towards the bottom. There's a link to a list. And sometimes those are out-of-state labs. It means that they've done the legwork to be approved in Alabama, even if they're somewhere else. And especially today with overnight shipping and some of those things, you have labs that are in strategic places in the country that can serve all 50 states, or they have, one company may have 7 or 8 labs around the country in strategic places, and they ship it to the nearest one, but they send you the kit, you ship it back, all that sort of thing. But they've got approval in Alabama, which means that it's certified for any community water supply there. And to me, that's the litmus test for a lab you should use for sampling. Another example, New York State. ELAP is the name of the program for certifying labs. And there's a list telling what you want. South Dakota, I'm just going through some examples of labs that are certified. And Oregon here. Yeah, so. And one thing I will tell you is you might run across this, especially if you use EPA's webpage to find it, because they don't necessarily keep that page as updated as it needs to be, or, I'd say every year at least 1 or 2 state agencies redo their website. And so unless that's been caught up, don't be discouraged. Just search for, in this case, Virginia certified labs, and it'll get to the right page under the Department of General Services here. And so that's what I did, found it. And and you can, again, it's just doing a little due diligence and doing a little searching. So as far as interpreting results, I forgot to include something here. You can use a website. There are websites where you can type in all the results and it'll give you some information. But I always recommend to a well owner that they take it to a qualified person, typically your county or state health department, and ask them to review your water analyses, because their job is to help protect your health. I'm not a health professional. I'm a groundwater hydrologist. I know a lot about these issues, but I don't have the qualifications, at least in education. And it's always best to talk to a health professional about what you should do next. And if you run into someone at a health department that may not be able to give you the answers you need, they will know who to send you to if they can't answer your questions. Not everybody has the same experience, and they don't want to give you the wrong answer either, so they may send you to someone else. But either way, they're the place to start with. And if you do find something, one of the things we recommend is you can always resample. If it seems odd or whatever, like for instance, if someone sampled a well in Tazewell County and they came up with a result of 45,000 ppb of arsenic, that can't be real, not in what we know about that aquifer. And I would resample. It maybe should be 450. Maybe they were doing a dilution. They split the sample and they calculated wrong, or who knows. But sometimes it might be worth resampling if it seems odd. And again, the folks in that local area will know if that fits with some of the other results they've seen. And if you sample for coliform and find coliform, then you should also sample for E. coli. That's the one that does make you sick. And regardless, you should boil your water until you can chlorinate your well or disinfect your well. I mentioned funding, financing. So there's a lot to being a private well owner. drilling the well or replacing the well and the water system components, sampling regularly. As far as protecting your well, managing not only your septic system, but if you have any abandoned wells, adding treatment if it's needed, and maintaining those devices, just regular maintenance and upkeep, and being sure, eventually you have to replace your pump. It's a mechanical device and those sorts of things. So there's a lot to it. And, one that says many well owners don't understand these responsibilities. If your pump fails and it's going to cost $4,000 to replace it, are you ready for that? And so even though you have a private well, some people's like, well, I have a private well because I don't have a water bill that way. You're best off if you create your own water bill for yourself. Put $25 a month, $50 a month, whatever it might be, into an account and have it there so that whenever your pump does fail or something else does go wrong, all of a sudden you're not looking at a $4,000 bill for a new pump. And that's if you're not in California or New Jersey or someplace like that, where it'll be 3 times that, or a new well where, Katie called a bunch of drilling companies all over the country, not a bunch, 7 or 8 in different states. This is probably 7 or 8 years ago. And we found the cheapest well, 200-foot steel cased well, was in Missouri at $6,000, and the most expensive was in New Jersey, and it was like $28,000. Well, today that $28,000 well would probably be at least $50,000, and the same in California. We see wells regularly costing $50,000 or more because of how deep they have to go today. Some of the aquifers there have dropped 300-400 feet or more, and so having money available or understanding what it could cost eventually is an important concept, because as you'll find out next month when we do our webinar, there just aren't a lot of options for a private well owner other than taking out a personal loan to get those funds. It's going to come out of your pocket. So as far as funding issues, as I said, you're individually responsible for managing your water supply. And again, the USDA has a national program where they provide funds. Sometimes there's local programs or state programs for some kind of assistance. Usually considered a private property issue though, so that means you're on your own, and it's all expensive. So the thing about like the USDA program you're going to hear about next month is they're mostly loans. They're low interest, but they all have income limitations. And so, especially for the grants, it has to be really low income in order to qualify for a grant for, replacing a well or septic or adding treatment. But, and so that's something to certainly be aware of. As I mentioned, funding financing options for private well owners. It's our webinar next month. We're very fortunate to have Dolores and Andrea from USDA talking about the 2 programs USDA has. And so it's on our webpage, privatewellclass.org. If you click on webinars, you'll see the February one listed there. You can register. I just took a screenshot of part of that, and we'll talk more about that then. The other thing is emergency situations. We work with the Texas Well Owner Network. They're actually a partner on the same grant, and they do a lot of great work in Texas. They put on workshops for citizens there where they also collect samples, but they also deal a lot with emergency situations, like needing FEMA. So, the hurricanes they had, I know in 2017, the hurricane that year, they worked with a group at Virginia Tech, and they sampled nearly 1,000 wells, I believe, that were flooded in the Houston and south of Houston area to find, what all those issues were. And again, FEMA is probably the best bet if that happens, and as far as a disaster happens. But also states, also have programs in place, which we'll go over next month. And if you know of a program like that, please let us know. So I'm going to talk a little bit about the private well class real quick, and then we'll get to your questions. So it's a 10-lesson class. These are PDFs that are emailed to you over 10 weeks. So it's completely self-paced. You're completely on your own to read it. But these webinars are not the class. They're much more detailed. Each lesson 6 to 10 pages. It provides diagrams, a lot of diagrams of information. And so these webinars really are meant to support those lessons. But if you haven't taken the class, you should sign up for it. It's all free. Again, it's sent to you as a PDF once a week for 10 weeks, and you're on your own to read it. For every person that says, hey, once a week isn't fast enough, we have another person that says, hey, once a week is way too fast. I don't have time to read this. And so it really depends on how busy you are and all those things, but you'll have that information as you get a chance. And so this is our front page of our website. Just click on Take Our Free Class or Learn by Email, and it takes you to a page to sign up, which I don't think I have on here, but it only asks 3 questions: your first name, your email address, and what state you live in. And what state you live in is really for us to show our sponsor and funders that we're reaching folks all over the country. And we've had over 11,000 people take our class already, and I think we're up to probably 11 or 12 different countries. We've had folks from the other countries take it as well. It's really useful. It's been vetted. It's got a lot of good information. And we're here if you have any questions. The bottom of this web page is an email address and a phone number, and we get calls every day, or almost every day, from folks. For each of the lessons, like the first lesson is called The Science of Groundwater, we include a bunch of resources in the resource library that are on similar information, so that if you read those 6 to 10 pages and something doesn't sink in with you, you can do your own extra homework, if you will, and look at some of these other resources, which are all clickable links that may explain the concepts in a better way. The class is written such that it's like someone talking to you, and if that doesn't resonate with everyone, then you can look at these other resources. And there's a set of these for each of the 10 lessons. We do webinars like today. In October, we did WellCare 101. It's recorded, now it's on YouTube. The neat thing I think about our webinars is the fact that we do allow people to ask questions in advance. Every month they're different. And so if you go to these webinars, you'll find, we do WellCare 101 at least twice a year, sometimes maybe 3 times. So even though the front half of the material is the same, a lot of times the questions in the back half are different. So you can go an hour and 10 minutes in or so and get to the questions and see different questions. So it's a good way to learn more about the questions people are asking, the problems they're having, and solutions that we're trying to provide. Once a year, we do a webinar on septic systems. This is really meant to be more of a private well and source water protection type of program, not specifically on septic systems, but we're getting more involved, and we do once a year. They're so important depending on where they are, what type of soil you're at, how shallow your well is. If you have bacteria or coliform E. coli problems, one of the culprits could be your septic system. And so we try to talk about best practices and all those things. And we bring on a septic expert who is in part of the RCAP network to answer questions there. He knows a lot more about septic systems than we do, or I do. And we've done a few of these specialty ones on things like lead. Now, we haven't repeated this since 2018 because we had an expert from Virginia Tech participate in this, and Dr. Kelsey Piper. She's now at Northeastern, but she did several studies back in the day, back and before this, working with homes that had lead issues on private wells. And so really nothing's changed as far as if you're a homeowner that has lead or galvanized pipes or copper pipes, really, because it's kind of the same thing. Copper is also a regulated contaminant. What you need to know about your water system is here. Lead isn't in the groundwater in your well. It leaches into the water from lead pipes, galvanized pipes, drop pipes, those sorts of things. And so on the lead side of things, it's really about if your water's corrosive or not. And so again, we haven't repeated this because I think all the information a well owner needs is right here. So you can look this up on our webinar library, our video library. We also created a page on information on lead sources and health effects and things from CDC and US EPA, and products, water filters that are been shown to lower lead in water that like go on your kitchen tap. It's just privatewellclass.org/lead, and you can get to this page there. And I mentioned the short videos like on flooding and fire. We have about, this says 16, this is a screenshot of an older video. I think there's 21 now or something. But even things like shared well, I get a lot of questions from people saying, hey, I share my well with 2 other people, 2 other homes, and we're starting to have this problem. It can be really a big issue if it's not in your deed, if you don't have a contract between the 3 of you on an agreement. Whoever owns the well has all the rights. And so we see a lot of folks who've been neighbors and friends for 10 plus years all of a sudden not be so neighborly when there's an issue. And 2 of the 4 people are willing to put up their share for a new pump, but the other 2 aren't. So it's really, if you're in that situation, it's good to understand what your issues could be and maybe try to right that wrong. Even having an account that everyone puts a little bit of money in so that when a pump does fail, there's money there to fix it. Pressure tanks, why does my well keep losing pressure? We have another video called How Does My Pressure Tank Work? That's had over 400,000 views since 2016. Obviously, when you're on a private well, you have your own pressure tank. Nowadays with variable speed pumps, you see more pressure tanks that are just there to help get started, a gallon or 2 gallons. But if you have an old style or a larger pressure tank, if it's not set right, if something's leaking, your pump could be kicking on all the time because of something in your pressure tank. Understanding those things is important. And that's why some people don't have very good water pressure. We started a podcast in 2021. So there's been 2 seasons of 12 episodes. We try to bring on experts and just have a casual conversation about things related to either wells or public water supplies. These 2 in particular are both on the private well side. Dr. Alan Wolf at the bottom is the head of pediatrics at Boston Children's Hospital. He helped rewrite the American Association of Pediatrics technical guidance on private wells, and he works with problem cases in children that sometimes end up being a water well problem. And so it was a really interesting conversation about some of those issues. But there's 24 of these episodes, or 25 now. And if you're into that, it's called Tap Talk, the Drinking Water in Rural America podcast. I didn't put the URL up here, but it's just drinkingwaterpodcast.org. And you can email us if you need that link. The entire class is available in Spanish, along with all the figures. If you are a professional and you work in an area with a lot of native Spanish speakers that have private wells, they can take our class this way. URL's at the bottom there, and you can email us to get that information. And in the end, I guess this is what we're after. We're trying to serve well owners, help them understand why their well is important, why they really need to understand how it works, so that they can really protect themselves and their family from risk, especially water quality risk. And so it's meant to be a one-on-one class to give people enough knowledge that they can ask better questions. I mentioned that earlier, as well as have an understanding, like if they're going to have issues down the road, depending on what we know about their aquifer, or what they have learned about their aquifer, or water use in the area, all those things that matter. So we're going to go to the questions that were submitted. And again, if you have a question, you can also ask. Looks like we've got 8 questions already from folks today, so we'll get to those at the end. As far as, I'm just going to go through some of the questions we got today. Some of our wells are in swampy type ground and another is within 30 feet of a stream. Is there a reason for concern for contamination? So it really depends on the well construction and seal around the well. The grout I mentioned earlier, you put grout, which is either cement or clay, around the outside of the well casing to seal the borehole so that things can't go down around the outside of the well casing from the surface. How shallow is the well? We're talking about in the swampy type ground. If it could be a 600-foot well in bedrock, and if it's completely sealed properly, it doesn't matter what the surface ground is at all. But if it's a shallow well and it's not properly constructed, it's older, you know, it could be a problem. So really, you need to know all those things as well. And as far as you know, how deep the casing goes, again, if it's bedrock, then if it's got 10 feet of casing, that's really bad. If it's got 200 feet of casing, that's really good, most likely, as far as protecting from surface influence at all. And then as far as being that close to a stream, you know, most of that bottom ground that's what I'm used to calling it. I grew up near bottom ground, and actually in those areas along the stream. If it's likely that it can flood or be overtopped, then that's really the risk. I know of a well that I drive by all the time going, my mom lives about 80 miles from here. There's a well that's right next to a stream because that's where the only place there's really water in the alluvial sand, but their casing goes up almost 10 feet above land surface. And, you know, that's a pain if they have to open up the well and do anything, but it's steel case, but they have the casing going up that high so that when that stream floods, the water's not going to overtop the well casing and get in through the cap. So if it's not that, if it does get flooded, you know, the big thing is if the well's been overtopped or water's gotten around the well even, you should just assume it's been contaminated and test it first. And if it's got coliform or E. coli or anything else, then you should disinfect. And that's kind of, you know, it's something to be aware of. You know, I can't tell you how many times people have bought a property that's on a bluff above a small stream or a river, only to find out that up on the bluff there's no water, and you have to put your well down in the bottom ground because that's the only place there's any sand or there's any water available in a, you know, shallow aquifer, alluvial aquifer. So they're pumping water back up to their house. And that's, you know, that may be your only choice, and I get that too. Is it a good sign of a full well after a rainstorm when I see it spitting out a stream of water out a hole in the pipe near the top? Well, so this diagram is a great example, kind of a long-term thing here, but when you have an aquifer, like in this example, the confined artesian aquifer, and it's kind of got the bluish stuff in it to mean it's saturated. The natural water level where the recharge area is you know, really high, right? And as you move from right to left, this shows a flowing artesian well because the static water level, and there's a mistake on here. It says static water table. It shouldn't say that. Is higher than the well, top of the casing. So it flows out the top. And the one on the right that says artesian well, you know, it's higher on the landscape. And so the static water level is still below the top of the casing, but it's well above the aquifer. So, I mean, think of this like a juice box. If you were to squeeze from the right side and squeeze a juice box and that well were the straw, it's going to come out the straw. If this happens only when there's a rainstorm and it happens right away, that means that water from the surface is getting into the aquifer and affecting the pressure in your aquifer where your water's coming from quickly. And if it's getting there that quickly, then it's likely not only due to the pressure, but it also means that some of that water could be getting in your well. And so to me, if it's done really quickly, if it gets, you know, if that starts spitting water pretty quickly, then you should test your well and see if you have any surface influence there, if there's any bacteria or issues. Because you know, the pressure should take a little time. It's great. You know, I remember we had 12 inches of rain over a week, and about 4 days later, we started seeing wells that started to flow that hadn't flowed, you know, in 20 years. And it's because all that water soaked in and eventually got to the aquifer and just increased the pressure in the system enough that water started flowing out the top of these wells. But it didn't happen during the rainstorm or within, you know, a few hours of the rainstorm. It was days and days later. And so if it happens that quickly, then I would say there's potential that there's a direct conduit into the aquifer from the surface, and that's why you're seeing that. Oh, I forgot to bold this. Recently, we purchased a home that is on well water. We located the individual that dug the well and requested the well log. He never responded. I think I left this in from a different presentation. Yeah, I'm going to skip this because I forgot to take this out. I apologize. So yeah, I mentioned earlier New York State didn't keep well logs before 2000. And the only place to look is with the driller itself. And you need to keep, if this were the situation today, be pushy. Even, I don't know how far away it is, but I'd even go there and talk to him because he's the only person that's going to have the log, or he or she. So, do flow rates change over time? Should I test again to see if the rate has improved in the last 40 years? Originally, it was 0.9 gallons per minute, which is really low. It'd be considered a low yield well. I'm not sure how you even are able to just use the well itself without having a tank to pump water in when you're not using it at that low of a rate. Would a new location be better if I want to develop a community well? And there's more to this question. I just kind of paraphrased. They're asking if they tested it and the rate was up, would they be able to use it for a community well? Well, if it's only 0.9 gallons per minute, that's a really poor well. Even at 9 gallons per minute, that's not enough for a community water supply. It might be enough for 2 homes. And so it's really not. And what ends up happening in most cases is your flow rate doesn't go up over time, it goes down because one, there could be scale buildup on the inside of some of the pipes or bacteria buildup of some sort, biofilms. If there's any kind of scour, meaning if there's any solids or any sand or anything else that gets pumped, eventually that makes your pump less efficient. And so we see this a lot in irrigation wells that are in sandy areas. A little bit of fine sand starts getting in a well, gets through the gravel pack in the screen, then eventually the pump efficiency goes down. It takes a lot more energy to pump the same amount of water, or if you don't have the opportunity to increase that like that, then you start seeing less flow than you think. And so at this really low flow rate, I don't see how there's any way that's going to improve, if anything. And if you do want to put in a new well, then you should talk to your local driller or your state geological survey, because really they are your best bets to get more information about if there's other sources at your location. But I will say, even 40 years ago, most drillers knew enough about the areas they were drilling in that if that's what your well pumps, then that's likely the way it's going to be anywhere on a small property. It's not like you're not going to move over 100 feet and be able to get 900 gallons a minute. If that's the case, they would have put the well 100 feet away where they could get 5 gallons a minute or more. Because I'm guessing if you only pump 0.9 gallons a minute, then you have a cistern or some other tank that your well can pump into when nobody's using it, and then you pump from the tank when you need it, because otherwise you wouldn't have enough supply even for a shower at that low rate. Is there a limit to the number of livestock that can use a well? So really, this is really a question about how much water your well pumps, right? And that's going to, depending on the type of livestock. I think you mentioned horses here, but let's say a horse uses 50 gallons a day on average through finding out from Co-op Extension or Department of Ag. What does your well pump, and what can it pump into perpetuity to ensure you always have a water supply? And so to do that, you really need to understand what the safe yield is, which is how much water can it pump, forever. You probably need to conduct a pumping test to measure the flow rate and the water level decline. So it's really like what was on that well log earlier, where you pump it for so long at a given rate and you can see how much drawdown there is. And then that'll give you an idea of, because if you pump it harder, it draws down more. That's just a fact of the way water flows through the ground. The equations that govern groundwater flow to a well are the same as electric flow. So the more you pump, it creates, yeah, it follows that same approach as far as if it's really important, or you're talking about a lot of livestock, then you'd want to do a longer test than 2 hours, like 3 to 7 days, and then you'd be more assured that you're not going to have an issue, because it's possible to pump a well even for several days, and all of a sudden you reach the limit of the water in that given geologic unit that you're using, and then all of a sudden the amount of water you can pump changes. We saw this happen with a community water supply. Someone did a 24-hour test and it made it look like there was plenty of water. They put in an actual permanent well, and after about 3 weeks, all of a sudden other wells in the area started going dry because the whole reservoir, if you will, that made up that aquifer wasn't very extensive in the end, and there was no way to know that. And so you'd want to do a longer term test to make sure, and just let it run to make sure that the well's going to be able to maintain. And again, I showed this example earlier, but the static water level is 130. They pumped it 25 gallons a minute for 2 hours and it reached 160. Well, the pump here was set at 160, but they could have set it at 220, right? The only problem with doing that is if you get below the casing, then you risk if there's any fines down in the geologic unit, the rock, because of the fractures and rock rubbing against each other and that stuff, you're going to start pumping those. But you need to understand how much drawdown there's going to be, and that really determines how much livestock you want to have there. So this is the first time I've got this question. Most of the information you provide is for people on the East Coast or Midwest and not really tailored to anybody on the West Coast. Is there any way this can be corrected? And so this is my email address and my phone number. I'd really like to talk to you about this. We work hard to make sure that we're providing information for everybody around the country, and I need some help from you on what I need to correct related to this. And so, feel free to call me anytime. I'd like to talk about it. Getting my well log. I was told there isn't a requirement for well logs in Georgia, yet when buying a house, it's recommended you get a copy of the well log, which is what we recommend too. You should have your log if you can. Before buying my house, I asked 1,000 times to get the well log, got no reply from the builder or broker, and all I got was this handwritten receipt. How do I get something official? So if I want to say first off, if you're putting in a new well, when you sign a contract with a driller, or even if it's you're buying a property and it's got an empty lot and you're going to have a contractor put in all that for you, build your house and put in a well, you make sure it's in the contract that you get a full log that has a pump tested with it, where the pump set, all the information. You could even say, I want an Illinois well log filled out completely, and because those are available online. That way, you've got your information, because so many people do not have their well log. And so what I learned, first I called Georgia. Well, what I did is I Googled Georgia well logs, water well logs, and it took me, one of the first options was through the Georgia EPD. I can't remember what that stands for. Anyway, so that agency licenses drillers and sets well construction code, and all that information is available on their website, including a link to a list of drillers in the state that are, have the credentials to drill in Georgia. And now they're not all in Georgia, actually, somewhere in North Carolina. But so when I talk to them, though, they regulate high capacity wells, which is any well that pumps 100,000 gallons a day. So it's about 70 gallons a minute. So it has to be rated. So it's irrigation wells, municipal wells, industrial wells. They do not regulate, or they do not have logs for private wells. So I'm going to call them back, because I'm going to talk to the manager there a little more about, because it's interesting to me. But I looked at their contractors list and I just picked a random driller and I got the Raven Frost Drilling Company. So I ended up calling in Riddleville, Georgia. The person who answered, she was so nice and explained everything to me. In Georgia, a driller has to provide a letter of intent to the county health department when they're going to put in a well, and that's it. There's no log filed, there's no permit to get. They have to say they're going to put a well on this property. So after learning that, my advice to you is to call your county health department, give them your address, let them know, where you live, and see if you have any idea how new the well might be, ask them if they can tell you who the driller was. And once you have the driller, you should be able to contact them and ask them for the log. Since they don't have to file a log, the thing is every driller keeps their own log because they want to understand what the geology is at that location in case they're drilling, quarter mile away or half mile away, then the geology is likely to be similar, not necessarily, but likely. And so most drillers have a really great set of well logs of their own. And it's a matter of, just asking them if they'll share your log with you so you have it. And so that's, I didn't know that Georgia didn't require well logs to be filed for private wells, and I found that out today. So yeah, it honestly took less than a half hour to talk to two people and get all that information. And so hopefully, let me know if you find who that is and you're able to get a log. And the Raven Frost Drilling Company, they've been drilling, their current owner's been drilling for over 40 years. And I would guess that if you wanted to contact them, I don't know how far away you are from Riddleville, but she mentioned that they know most of the other drillers in the state. So they might even be able to help. Hang on. Okay, my local Board of Health has a book of old logs, but there can be multiple logs for wells installed around the same time in a subdivision. What are the best practices for local boards of health regarding such information? What are the rules around disclosing detailed well location data? Should public databases make anonymous some well location information for security? This is really a state-specific question. I think some of the other things we've shown today and answered make it really clear. Until 2016 or 17, you couldn't get a California well log unless you were the owner. And the fact that you have a Board of Health that has old well log information in a book somewhere is great. There might be other boards of health in your state. I'm assuming you're in one of the Northeast or New England states. That's typically where these boards of health are. Unlike in Illinois or in California where you have county health departments that have all that information. But like I'm used to Massachusetts and Connecticut, every Board of Health is really autonomous. They set their own rules. Some have no rules. I mentioned earlier today that in 99% of the country, they can't condemn your well. I met 2 health department people in Connecticut that are in a local health district who have the authority to condemn a well. And that's the only time I've ran across that. So I can't say they can't condemn a well anymore. But in most states, and like in Illinois, all their records are online these days. And so it's really a local decision. After 9/11 happened, a lot of states started hiding data, and most of them have relaxed that. Even our Illinois EPA, which regulates our community water supplies, they had a GIS map up on their website before that provided all the locations of wells, and they took it down. And you have to get that information, you have to get a formal request. And I think all that's changed back to the way it used to be. And so, I don't have a good answer. I don't think it should be protected. I think who owns a well and who drilled a well should be public information. And that's the way it is for most of the folks that I've worked with and what I deal with. And I don't know if that answers your question, but I don't think it needs to be made anonymous at all for security issues. In the end, even for a community water supply, there's all this worry that people are going to try to sabotage or poison a well. If you're going to if you're going to do those things, you would do it in the water treatment plant where the water is getting ready to go out to distribution, not in the well before it comes into the treatment plant where, there might be chemicals added and other things could change or might be blended, or, the chemistry gets changed because of even removing iron changes the chemistry of the water. And so I don't have a good reason for anyone to keep that stuff from anybody else. New Jersey passed a law in probably over 20 years ago now, requiring testing by the state lab for every property that was being sold that had a private well. And what they've done there is they report all the data in 2-mile blocks. So if they've sampled 12 homes in some 2-mile block and the arsenic level was 14, or the standard is 10, they'll list that maybe as red in this 2-mile block. So there's arsenic in that area. But they don't provide any individual data except to the buyer and the seller. And it's up to them to remediate how they want to deal with that. And it's actually a good model. 2 other states do that as well now, but New Jersey started it. And the cool thing is they use their state lab to do the analysis. And so they sample they're even sampling for PFAS now, I believe, but it's all an accredited lab. It's research quality data, and they get almost 13,000 samples a year. So over 20 years, that's 260,000 private well samples. Now, some of those are obviously the same well more than once, but the maps in New Jersey that show their water quality for their aquifers are really, they're really well defined. They're very accurate because they have so much data. And, I think all that should be public information. No one should buy a house that has a health risk because of a chemical or a property of the well water and not be informed of it. And we do a webinar for realtors, and the whole webinar's based on the premise of, if you're the buyer, here's what we recommend. If you're the seller, here's why we also recommend this. And in that case, if you're the seller, we recommend that you sample first before you even put it on the market. And if there is a problem like naturally occurring arsenic, you know how to remediate that. Put in the treatment device and make sure it's working. And then you can show that information to any potential buyers. And instead of the buyer saying, well, I'm going to take a water sample and you haven't done anything, and then they find high arsenic, all of a sudden they're going to walk away or they're going to distrust you, all those things. And so information is the most important thing. And if everyone worked on that premise and provided all that stuff in advance, a lot of these things would take care of themselves. My opinion. Finding a good driller. I have a pit well from one of the original settlers in my area. It appears to work satisfactorily and supplies potable water. What companies in the area are trustworthy partners to upgrade my current well to a pitless adapter? Well, you need a pitless is really for a cold climate where you need to run the line under the ground to keep frost out. If it's just in a pit, if it's in a pit, it's likely because of that. But you could just extend the well to the surface. The thing is, I don't know what state you're in or what area of any state you're in, so there's no way that I can answer your question on what companies in the area. So what I recommend is that you do your due diligence to find the right water or the right professional. Look in your state list of accredited or licensed drillers. Like I did for Georgia, I found a list of all the licensed drillers in Georgia. Find those in your state. Also call and ask if there's been any complaints against any of them. They won't provide that necessarily on their website, but if you ask, they may tell you. And this isn't a hard and fast rule, you don't have to do this, but the National Groundwater Association has a program for well drillers to become a master well driller. You take some classes, you pass a test, and you do a certain level of effort to get that designation. It does mean that someone went to the trouble of learning what they needed to do to become that, have that designation. And so it doesn't hurt, is all I'm saying. And then you can also look up their business online for reviews. If, these days that's available, although you have to be careful. One really bad review could mean a lot of things that have nothing to do with the quality of their business. Ask your neighbors. Our neighbors, any others, a lot of times, like if your county health department works with certain drillers, they likely won't give you the name of one, even if they like them the best, because they're not supposed to. I know we can't do that. I can't, if I know you're going to drill a well in a certain place, I may know which driller I would use if I were in that area, but I can't recommend that particular driller to anyone because it's the nature of my job. But you can certainly ask a lot of people if they know, and even ask the driller themselves for some customers in the area that you can call. All that said, there's a whole section on this, almost a third of a page or more, on questions you should ask a well driller in Lesson 7, so that you can help define what driller, that they meet your needs, that they're bonded, they will provide a log that you can, they're amenable to work with. And again, it's another reason why you should take our class, because I think there's a lot of good information in there, not only just about drillers, but just, treatment professionals, other folks that you may come across. Just like one of the best practices we recommend is that if you're going to drill a well, you hire a driller that also installs all of your equipment. So runs the line to the house, puts in your pressure tank and all that stuff. Because more often, a number of times we've run across where one guy drills a well, a different guy comes and installs the pump and maybe puts in the treatment, the pressure tank and those things. And then when there's a problem, one will blame the other, and then the other one blames the first one. And you have all this, no one's taking responsibility. If you use one company that does all of that stuff, there's no question about whose responsibility it is whenever you put in a new system. And so that's what I would recommend. And with that, we've got a number of questions. So what I'm going to do is I'm going to drop this. Wow, why did that do that? I don't know why. I'm going to bring this up and make it full screen and enlarge it so everybody can read it. Okay. Katie, everybody see that?
It looks good.
Thank you. Is there any way you can research where your well water comes from underground? Well, hopefully we talked about that today. I know if you called me, I know we have maps of both the bedrock aquifers and the sand and gravel aquifers of the state. I could take your location and look at it on a map, and we can plot it, or you can go to the State Geological Survey's website and their GIS application, and you can see, probably even find your well in that case. But your state agency that works with aquifers or develops those maps, again, if you Google My State Aquifer Maps, they may be online. You may be able to find it right away, like we did with Oklahoma. Are PFAS showing up in well water, and what can owners do? Yes. So PFAS, is showing up everywhere, in the air, in dust, in the ground, in our bodies, and in water. And so there are ways to treat your well water. EPA has a website with a list. I don't have that information available to me right here, but there are available technologies. I know I showed those podcasts earlier. I know Margaret Martins from the Water Systems Council. That's one of I think that's the tag, the sentence she said that we listed with that is, there are ways to treat it. So, there's existing technologies that can remove it. You just have to add the treatment to your system. And so you should be able to find that online, or email us and we can also try to help find that. I know we had a question today that was about, I can't remember what it was now, but it's really the type of question that I just have to call somewhere and ask. And if it's that kind of question, you as a well owner should just call and ask. And I'm not saying that about number 2 here. I just reminded me when I saw this question. But yeah, I guess the bottom line is there are conventional treatment methods that remove PFAS chemicals. And yeah, there's, even a treatment professional can help you there. And as far as treatment professionals, um, I mentioned someone who's taken a class and all that stuff. You do have to be careful. And in our lesson 10, we even talk about some of the issues with treatment professionals. I've gone to houses where they've got $5,000 worth of treatment equipment. And I'm like, what was in your well water? Well, we didn't test it. We just wanted to be safe. Well, the maintenance on that is, $700 or $800 a year. And, these people probably had the money, but most of us don't. And so, sampling is where you start. But if you get the right treatment professional, someone who's really a professional, they can help you with those things. And the Water Quality Association, WQA.org, has a list of treatment professionals that have taken, they have a designation, a certificate program, and part of that's ethics and all those things too. And there's a list, you can search by your zip code, I think, and it'll give you a list of treatment professionals that have met that designation in your area. And that's probably a good place to start for adding treatment. Okay, I work at a health department, and I had someone who got their well tested and had high bacterial level. They bought the farm not knowing where the well was. Oh no. And I didn't have any information on it. How would someone go about locating the well? They still have the well and use it for farm use, but they hooked their house to rural water. I'll just say first off that if they had the opportunity to hook up to rural water and it's a potable, if it's a rural water district that is regulated by the Safe Drinking Water Act, I think that's money well spent for anyone, just to not be responsible. As far as finding the well, I know for septic systems, a lot of times it's a straight shot from the pipe going out of your house. So if you have a basement, you can follow that line and then use a probe. But a water well line is probably not as large as the septic line would be. And it's probably a lot harder to find. But my first guess would be that if it was possible, wherever the water line comes in the house, it's straight in that direction. Yeah, it's interesting because just a few months ago, we had someone who had a small hole form in their yard. They were mowing their yard with a riding mower, and this 12-inch hole just opened up. And they called us, a colleague and I went out there to look at it, and it was actually an old dug well that had been buried. And she's very fortunate. It was almost 4-foot diameter, that only a foot of it gave way because her and her little riding mower could have all fell in there. And those things are a real problem. It's likely an old, large diameter well if it's on a farm. And yeah, it's a tough one. I'm not sure how to find it other than following the pipe. If you can probe it, and they have probes that you use for finding buried. It's just like a little T steel, thin as a pencil, or pencil itself, that you can probe in the ground with. That might be your best bet. You can also ask a driller if they have any ideas. When my well was drilled, the only test they did was an air test to test how much water can be pumped out. Is that good enough to specify the type of pump and motor to put in my well? So I haven't actually drilled any private wells for a home, but I've put in a number of monitoring wells, several hundred feet deep monitoring wells, working with a driller, where we develop those with air, and you run an air hose to the bottom, and you pump it out, trying to get all the drilling mud and stuff out. Whatever water comes in will create over the course of 20 minutes, as you're trying to get the water to clean up, the air will push so much water up based on how much can get in and how quickly. And so it probably is, depending on the situation. Well, it's not a very helpful thing to say. I mean, if they developed it with air and it provided a fairly steady stream of water, just a few breaks every so often, then there's probably a lot of water coming into the well. And so, your pump, if it's not a limitation of the well, like earlier the question where it was 0.9 gallons per minute, that's a well limitation and a real problem, like low yield well like that. If the well will provide plenty of water, then your pump really should be should be purchased to fit what your needs are. You know, no livestock, a single home, even with 4 or 5 people, I wouldn't guess you need more than a 5 gallon per minute pump. And I'm not an expert there, but you know, there's no reason to put in a 20 gallon per minute pump, even if it'll pump it. That's really just overkill and a lot of electricity. So, I mean, if the person who developed it with air feels like there's plenty of water there, then really you should, yeah, specify your pump and motor based on what your needs are. I saw an aero motor on one of the slides. To my knowledge, an aero motor is a windmill. Is this a wind-driven pump? I checked the Aerometer website. Aerometer makes windmills and electric pumps. I have no idea. I don't know that I put a windmill on any of the slides on purpose. Yeah, I mean, windmills are still actively in use. I was just at the National Groundwater Association Conference and Expo in December, where all the new drill rigs and all the new equipment are and stuff, a giant expo hall. And there are a number of companies selling large windmills, but you know, those are really for remote areas. They can work, they obviously still do. Yeah, it is a wind-driven pump. So, you know, just like a hand pump in the old days, or the pump I mentioned earlier, that's a motorized hand pump, basically. That's all a windmill does. Is it you know, it's on a shaft that alternately raises and lowers. Yeah, to lift water, and so they certainly are. I guess that's your question. And you still have areas, especially like in Oklahoma and Texas, where you may have a well that's, you know, 2 miles from a home because it's for all the livestock, cattle that are range cattle, that it's just a lot simpler to have a windmill that pumps water. And if it wastes some, that's fine. It's, you know, the cattle know where to go and find water when they need it. So I don't know how well that works for a water supply for a person. I guess that's your question. But yeah, they still work and are still in use. Oh, what did I do here? I went the wrong way. Okay, how accessible are these logs for people with disabilities or those with limited English proficiency? I would say if any of those issues come up for you, then you know, I would write it. I would try to contact somebody by phone and or maybe an email. Mention those disabilities, or that you're not a very proficient English speaker, and they should then, you know, if they're aware of that, help to work around any limitations that might cause, and get you the information you need. And so, you know, I was trying to show where you might be able to find things on your own, but if that's not going to work, then that's why those folks, like I said, are pretty helpful. I know if you contacted me by email and could give me your location and what you need, you know, I correspond with a lot of people. I've never talked to them on the phone, or they haven't tried to look at our website. We still have folks who live in the country who may be in their 70s or 80s and don't use a computer at all. Even for our class, I would guess at least 2 or 3 times a year, we get a request from like a county extension agent with an address saying, could you mail a printed copy of your private well class to this address for these folks? They don't use the internet and they don't have a computer. And so we print all 86 pages in color and bind it and send it to them. And so there's ways to do those things. In the same way with logs. You know, I email logs to people all the time, but I can certainly print them and mail them to someone as well. So it really shouldn't it might take a little more time, or it might take a few extra emails, but we should be able to get around those things regardless. So, is the well ID the same as a permit number? I'm in Colorado, so I don't know about Colorado, but for us, no. The permit is through the county, and it's a different even, it's like 2 numbers, a dash, 3 numbers, and then a dash and 4 numbers or something where, we may list the permit ID on the log, or it may. It's not something I ever look at because we have our own system since we're the repository for all the logs, not just at each county. It's called a P number, which, someone from before I was born decided that. But that's what we're stuck with. And so our well ID is a P number, and they're numbered sequentially when they come into our office. And so, we're up to, I want to say 496 or something thousand is the numbers we're working on these days. And so I think you need to ask someone in Colorado. I don't have that information. And to me, that's a smart way to do it. But not every well gets drilled, right? Everyone that gets a permit, or they drill a well and it's dry and there's no water, so they don't actually file a log because there's a fee usually with that. And so I think that's one reason why we don't do it that way. But yeah, I have no idea for Colorado. Recently bought a home with a private well. During inspection, we discovered the wellhead was cracked. The well was fixed and then tested. There was total coliform. The well was shocked and retested 10 days later. It was still there. We're going to install a UV filter to deal with this, but wondering what can be done to fix this total coliform issue. Original owners claim there've never been an issue previous to the wellhead issue. If it's been a long time and the well was never disinfected, there could be a buildup of, like biofilms. We tell people that before they assume that there's a continuous source, which, if there's livestock nearby or depending on where the well's getting its water, it could be a case where most of the water is coming from a very thin sand unit underground that extends, under the house over to where the septic field is. And because it's so small, maybe it's only 4 inches thick, and this is just a weird example, a lot of the water from the well into the well is coming from underneath the house or from that direction. If that's the case, then you're always going to have bacteria. It could be that if you shocked it 2 or 3 times, it'll clear up, and it depends on how you shocked it. We have recommendations for how that should be done. I've had people tell me that, a contractor or a pump installer said, oh, just pour a cup of bleach down the well every month, it'll be fine. That's the worst advice you can give somebody. And if you go through our older webinars, almost every one of them, we recommend what Minnesota recommends. We have a link to it on those resources I showed earlier, where, lesson 1 and lesson 2. Under lesson 10, there's a resource from Minnesota Department of Health. To me, that's the way you disinfect your well. You mix it based on the volume of water you have in your well. You circulate it through the well to make sure you're covering all the sides and all the equipment that's maybe above the water level. Then once you know it's mixed well, you run it through every shower, toilet, sink, spigot until you smell chlorine. Then you let it sit overnight. That's all necessary to make sure that you kill any bacteria that might be in your well or water system. It very well could be that there's a biofilm on a pipe in your house. And so, we recommend doing that 2 or 3 times before deciding that it's not fixable and going to a permanent disinfection method like UV filter or continuous chlorine. Just with a cracked wellhead, I wouldn't, I don't know how bad the crack was or anything else. I'd have to see it. But it might be worth trying to disinfect it more than once, I guess would be my advice. If you want to email us to, it's at the bottom here. Maybe you can send us a picture, or, this is a situation where one of the RCAP folks that we work with might be able to come visit you and give you their thoughts. So, like I said, each of the regional folks have done hundreds of these well assessments, and they certainly know a lot about wells in the states they work in. And so I'd be glad to give them your contact information, or I can give you theirs to see what you might be able to find out there. I have an old well that is not documented anywhere that I can find. No idea who the driller was. I suspect that it was drilled in the 30s. How can it be tested to provide the well data? So, you can have a contractor come out and measure the depth of the well, pull the pump to determine how deep the pump's set. You can even put a camera down the well and determine if it's, has a screen at the bottom or how much casing it has. All those just come with a cost. If it was drilled in the 30s, it seems like it's very likely, unless the pump's on top, like a suction pump or or a jet pump. If the pump's down in the well, then it seems like it's very likely that the pump has been replaced in the last, 20 years or so. And that's not always the case, especially a pump that's up at the surface, like a suction pump or a jet pump. I have a buddy that has one that it was installed in the 70s and it just went bad 50 years later. So it's possible that they'll last that long, but maybe you can find out if from a previous owner or something, if someone did any pump work, because it may be that the pump installer has some information about the well. That's the only other thing you can do besides have someone come out and, measure the water level and the total depth of the well after they pull the pump, if it's in the well. And to really get details, you can run a camera down it. But I don't know, it depends on where you're at and the availability of that. I know we just bought one to use for the work we do, but it's, and the camera, it's probably going to cost some money as the bottom line, but you'll know. And it certainly won't cost as much as a new well. So I found the online state well log information site for my well, but there's no information available. The same no information is showing for the near area wells. The homes are generally built in the 70s. I need to hire a well driller to figure out more information. Water tests over time have been fine. Records received from the previous homeowner for their 7 years on our tests the last 2 years. Contaminants, hardness, and flow rate. It's up to you. What I just said about the other one, if you want to know how deep your well is, you can certainly have it measured. But you're not going to get the geology. I forgot to mention that, but either way, you're not going to have the geology unless there's a nearby well. And, that's the other thing for number 9 up here. If you do that, then you can look for another well that's in the area, potentially that's a lot newer, that at least has the geology and it's near the same depth or goes deeper, and then at least you have an idea what your geology is. But as far as this question, I don't know what information you need other than where your pump's at. Is good to know. I think, the most, you've done what I think what's the most important thing is that you have sampled and you're having the flow measured, which, that's a new one to me too. In some states, flow measurements are commonly done by contractors, but not in Illinois. A lot of times we only have what's on the log for a flow rate. And so, that's really useful information. The only concerns you could have down the road is if your pump's not set deep enough, or if there's a lot of use in the area and the aquifer's going down, have water level measurements. But if they're measuring flow rate, hopefully they're taking a static water level measurement every time too. So I don't know that you need to do a lot. So I think that's, especially the testing is the most important thing, right? So, and it sounds like you have plenty of water. I'm trying to learn in North Carolina, but I'm a quarter mile downstream from a 150-year-old orchard and perennial stream where farmers are also spraying atrazine, plus there's a cattle feline affecting my well. Through a plumber, I was hospitalized for septic, E. coli, and 28 hours on IVs. I believe my watershed initiative needs to teach neighbors testing and proper sanitation. Is our well undrinkable now? This is a much deeper question that I can answer without a lot of information. And if you're talking about litigation, those issues, I'm not qualified to deal with all that. And if you've contacted your state folks, that's the best place to go. Yeah, and then, as far as litigation, you need to have all that documented and all those things. I'm sorry for your trouble, but I don't know that that there's anything additional I can do for you. Yeah, other than suggest that you contact your state agency that deals with your wells. What's the best source for well water filtration support? Our well water has a sulfur smell at some sinks. Well, so that if it's just at some sinks, it could be from your water heater. Boy, I wish I had. I'd have to look this up. Could be from iron bacteria or sulfur bacteria. As far as water filtration support, there is a document that from the Minnesota Department of Health called Home Water Treatment. And actually it's listed on our resource list, or it should be. If not, Katie needs to put that up there because I forgot to do it. But if you Google Minnesota Department of Health Home Water Treatment, there's a document that talks about every type of water quality issue and how to treat it. It's an amazing home water support document, and I would go there. Minnesota does it right. They have a lot of resources and they have a lot of wells, and so they have a lot of staff devoted to working with those folks. So it's 3:15, I just realized, my time, and so we're going to end the webinar. Thank you everyone who stuck around, and if you have any further questions, you can email us at info@privatewellclass.org, and you can also email us for certificates, CEs, all those things if you are looking for that information. All right, thank you. Thanks for all the questions.